Today my video is on limiting reactants and percent yield. A limiting reactant is the reactant that runs out first in your equation. So if we had an equation like A plus 2B yields C, we have 1 mole of A, 1 mole of B. We're trying to figure out how much of C we can get. So we'll just skip right to the real example because that's fun. And in this one we have 1.85 mole of NaOH and 1 mole of CO2. What we're going to try to find is how much Na2CO3 we can produce. So first we're going to take the 1.85 mole of NaOH divided by the moles given, which is 2. So 2 mole of NaOH. And then the next thing we do is convert that to moles of Na2CO3. So in our equation we have 1 mole of Na2CO3. And then you just type it in to find the number of moles of Na2CO3 you can produce. And in this case, we can produce 0.925 mole of Na2CO3. And then in order to find the limiting reactant, we also have to consider CO2. So if we go over here, we're given 1 mole of CO2. Then in the equation, we also have 1 mole of CO2. And then we'll want to convert it to moles of Na2CO3, which is also 1 mole. So together it can produce 1 mole of Na2CO3. So that means our limiting reactant is the one that produces the least amount of moles, which in this case, the least amount is 0.925 mole, which came from the 1.85 mole of NaOH. So that means NaOH is the limiting reactant. And then if the problem asks for grams total that can be produced, you would take this number, the 0.925 mole of Na2CO3, and divide by the mass on the periodic table to find your grams. Then the second thing I'll talk about is percent yield. With percent yield, it is actual over theoretical times 100 equals percent yield. So it's not too difficult. So then we have our equation down here. CaCO3 yields CaO plus CO2. In the problem, it gave us that we have 15 grams actually. So what that means is that we need to find the theoretical yield from this equation. So, and we also know we had 30 grams of this. So this one's another T-chart. You would take 30 grams of Ca CO3 and divide that by the mass on the table, which is 100 grams. And that converts it to moles. Then we want to convert it to moles of CaO. So in the equation we have 1 mole of CaCO3 and 1 mole of CaO. Then the last thing is converting that to grams. So 1 mole CaO has a mass of 56. And in the end, this equals 16.8 grams of CaO. So this is our theoretical number. So then all you have to do is take 15 divided by 16.8 times 100 will then equal 89